Okay, so we're going to be starting with some questions. Now, mine don't exactly line up with your guys's because I'm not going to do proofs till the next lesson. So we're going to just practice some techniques that we're going to use in future proofs. We're just going to factor, and we're also going to be simplifying just to practice. Next week, we're going to spend a whole lot of time on practicing proofs. So this is 5.1 part 2. We're going to practice first factoring. So you're probably going to want your formula sheet handy when we do this lesson. So again, my numbers aren't going to match up with yours. This one is actually example 1 and this one is example 2. So let's start with secant squared minus 1. So one thing when we're factoring, right, when you go think back to algebra 2, when you have two terms, you want to check and see if it's a difference of squares. So these are both perfect squares. I can factor this. If this was x squared minus 4, we would factor that as x plus 2, x minus 2. So I'm going to do the same thing. This would be secant plus 1, secant minus 1. So we can factor trig functions exactly like we would factor a regular algebra problem. So let's look at number 2. We have 4 tangent squared plus tangent squared minus tangent of theta minus 3. So if I wrote this instead with x's, 4x squared plus x minus 3, we would factor that. Now, you guys might have learned a couple different methods, and we reviewed this year. When you have a number in front, you can either do the guess and check method, or there was the 4-part method, the ABCD method. First step is we multiply the first and last number, so x squared plus x minus 12. The second step is we factor that. So 4 times 3 subtracts to give us 1. They're going to be different. The bigger one's going to be positive. Then I'm going to plug the 4 back in front. And then we reduce. So x plus 1, 4x minus 3. So it's the same process with a trig function. So instead of x, though, we have tangents. So I would write this as tangent of theta plus 1 and 4 tangent of theta minus 3. So if it helps and you want to do some side work and use x's instead to help you factor it, you can do that. Just make sure you go back in, convert it back to trig functions. Okay, so this is your example 3 and 4 on the back. So let's try number 3. Now, here we have a little bit of an issue because I have cosecant and cotangent. Now, when we factor, we want there to be one trig function. So I'm going to use my formulas to help me here first. If I look at my Pythagorean identities, and I go there anytime I see a square, I see that cosecant is equal to 1 plus cotangent squared. And I'm going to bring down the rest. So I'm going to bring down the minus cotangent squared minus 3. Now the nice thing about this is that these cotangents now cancel, and I'm just left with 1 minus 3. So that's negative 2. So in fact, I didn't have to factor anything here, but I could simplify this down to just negative 2. Okay, let's try number 4. We have the sine to the 4th power of x minus cosine to the 4th power of x. So both of these are perfect squares. I could do a difference of 2 squares. I could do sine squared plus cosine squared and sine squared minus cosine squared. Now right away I see something that looks familiar. I see sine squared plus cosine squared. If you look at your Pythagorean identities on your formula sheet, that is the same thing as 1. And over here, I have another difference of squares, so I can keep factoring that. That's sine plus cosine times sine minus cosine. So let's move on to some more simplifying problems. So these are all going to come up again later when we do some more complicated proofs. They're going to require us to use some simplifying things. So one thing we want to do when we simplify, right, we can factor, we can multiply, we can convert everything to sine and cosine. So I'm going to make a list here. We can factor, we can multiply, we can convert everything to sine and cosine. If there's fractions involved, we could combine fractions to get one term instead of two. And another thing we want to make sure we reference is our formula sheet. Right? We can substitute in things that might be simpler to help us simplify our problems. So let's start with this is your number 5 here. Sine plus cosine times, sine plus cotangent times cosine. So I can't factor anything out because there's nothing in common between these two terms. There's nothing to multiply, but I probably could try this converting everything to sine and cosine. I have a cotangent that I could write as cosine over sine. Sometimes it may look like you're making it more complicated, but sometimes you'll see it'll work out in the end, hopefully. So this is sine plus, now these two cosines I can multiply, that's cosine squared over sine. Now I've got a fraction plus another term. So what I'm going to do is get a common denominator so I can add these up. So I'm going to write this as sine squared over sine. That's the same thing as sine. I've gotten my common denominator. So now I can add the numerators, sine squared plus cosine squared over sine. Now on my formula sheet, I see squares, so sine squared plus cosine squared is the same thing as 1 over sine. And that's a reciprocal identity. 1 over sine is the same thing as cosecant. Okay, let's go on to question number 6. Now 6, I can't factor it, it's already been factored. Another thing we could try is to multiply. I could multiply these together. I'm going to have to FOIL that to do that. So first gives me cosecant squared. Outer and inner would cancel since these are conjugates. And then last would give me minus 1. Now I see a square. So I'm going to go to my Pythagorean identities. Let's see if we have anything for cosecant. Cosecant squared is 1 plus cotangent. So I'm going to write that down. So that'll help me because I can plug in 1 plus cotangent squared for cosecant, bring down my minus 1, and the 1's will now cancel, and I'm down to just one trig function. So remember, your goal when you simplify is to either get down to one term or one trig function. Okay, let's try number 7. 7, I have 2 fractions, so right away I think I probably could combine them, and hopefully we can cancel some things out. Now my common denominator is going to be both of these denominators, so I'm going to have to multiply the first fraction by the 1 minus cosine, and the second one by the 1 plus cosine. So my common denominator would be 1 plus cosine, 1 minus cosine. And then the top, 1 minus cosine plus 1 plus cosine. Now, looking at the top, the cosines cancel, and I'm left with 2. Now on the bottom, I could try to FOIL that and see if that does anything for me. So first would give me 1. Outer and inner would cancel. Last would be minus cosine squared. Now I see a cosine squared. So on my formula sheet, I know that sine squared plus cosine squared equals 1. Now you can manipulate the formulas on your formula sheet. If I need a cosine squared, I could solve this for cosine squared. That would equal 1 minus sine squared. And I could plug that in here for cosine squared. So 2 over 1 minus sine squared. So what does that simplify to? Let's see here. I got 2 on the top still. 1 minus 1 gives me 0. And then this minus distributes over here. It'd be sine squared. Now you can leave your answer like that because technically we have one term and one trig function, or we can write this as 2 cosecant squared because 1 over sine is cosecant. So you can write this as 2 cosecant with a square since the sine is squared also. Okay, question number 8. We have tangent minus secant squared over tangent. Now, I have a fraction, so one technique is I'm going to try to combine these. But I need to have this have a common denominator, which also needs to be tangent. So I'm going to make this top squared. So tangent squared over tangent gives me my common denominator. So now I'm going to combine tangent squared minus secant squared over tangent. Now, right away, I see squareds. I'm going to go to my Pythagorean identity section of my formula sheet, and I see that it says 1 plus tangent squared equals secant squared. So I'm going to use that. I'm going to plug in for secant squared 1 plus tangent squared. Now we're subtracting a quantity, so make sure you put that in parentheses. Okay, so I'm going to distribute this negative. Tangent squared minus 1 minus tangent squared over tangent. So the tangents cancel. I'm left with negative 1 over tangent. You can leave it like that, or if we remember, 1 over tangent is the same thing as cotangent, so negative cotangent of x. So when we go to practice more proofs, we're going to be using all of the techniques that we did in today's lesson, like factoring, foiling, getting a common denominator so we can combine fractions, and we're also going to be using our formula sheet to help us convert trig functions into other trig functions.